This is video lesson number 2 for level 1. We're looking at chapter 1, section 4. Primarily going to be talking about segments, rays, parallel lines, and planes, adding more vocabulary to our first lesson. We're going to start right away with segments. Now, segments are part of a line. We learned what a line was in the previous lesson. It was the set of all points, so infinite points that extended in two opposite directions forever. A segment is part of a line, just a small portion of it, and it contains all the points between two endpoints. So a segment has a start and a stop. This introduces our first finite element for geometry. Finite meaning something we can actually measure. A segment can be measured to be 5 feet, 5 inches, anything like that that has a measurement to it. So, segment AB starts at A, ends at B, or vice versa, technically speaking, and we mark it AB with a segment above the A and the B. There are no arrows, so we are saying that it does not go on forever. In the picture on the screen, the line in red, or the segment is in red, the line continues with the black dotted lines. We have to be able to visualize that the segment is part of a line that goes on further. So, our first question to be thinking about when writing these notes is, what is the difference when we read line AB and segment AB? Primary difference, line AB goes on forever and has no measurement. Segment AB is finite and can be measured for a specific distance. An interesting difference that comes from that is that a segment can have a midpoint. We can introduce something that would be considered the middle, whereas a line would have no middle. It goes on forever. You can never find the middle of the line. So a segment can have a midpoint. One interesting similarity is that there are infinite points on a line, and even though this segment is only from A to B, there are infinite points between A and B. Same number of points. What about this question? What about segment AB versus segment BA? Are they the same segment, or is it different if we say starts at A and ends at B? Starts at B and ends at A. The answer is yes, they are the same segment. The number one reason to understand this is to not think of it as start at A, end at B. Rather, we should think of it as it is the set of all points in between A and B. Well, that would be the exact same set of points that is in between B and A. It's a set of points. This is actually a description. We are describing something. Okay, let's describe something a little different now. A ray. A ray is a set of points starting at one endpoint and continuing forever in one direction. So this is kind of the middle ground from a line and a segment. It's not a line because it doesn't continue in two opposite directions. It goes only in one direction. But it's also not finite like a segment. It cannot be measured. It goes on forever. It has no middle. The red shows the ray, ray XY. The black shows that it comes from line XY, but we are starting at X. This, specifically ray XY, says that it starts at X and goes through Y. This is very important. No matter what, when we read our textbooks, when we read the PowerPoints, worksheets, anything like that, the first letter for a ray is where it starts, the second letter is where it goes through. So, when we ask the question, are ray XY and ray YX, are these the same ray? The answer in this case is no. Those are not the same ray. One of them starts at X and goes through Y. That would be what we see here in the red. The other one starts at Y and goes through X. They describe a different set of points. Notice we do not write XY with the arrow pointing to the left. We read left to right, so therefore as we describe a ray, we put the starting letter first and then the direction second. Even if the direction in the picture is to the left, we still name it by putting the arrow to the right. This arrow has nothing to do with direction. It has to do with the symbol that means it is a ray, where this is our description. One way you can think about it is, if I drew this, here's point A and here's point B, we would still write A, B, to say start at A, go through B. We would never draw the arrow pointing up. Okay? Next up, opposite rays. As you can see, opposite rays share an endpoint and extend in opposite directions. When you put two opposite rays together, they form a line. Currently, ray PL and ray PQ are opposite rays. They both start at P, and then one describes the set of points that goes through L, the other starts at P and describes the set of points that goes through Q. They go in opposite directions with the exact same starting point. There is no overlap. So if I was to say ray LQ and ray QL, these are not opposite rays. They have opposite direction. That's a yes. Opposite direction. Do they have the same starting point? And the answer to that is no. They don't have the same starting point. These are not opposite rays. Next up, ray LP and ray LQ are the same ray. They have the exact same starting point and they extend in the exact same direction. Well, this is kind of interesting because these have the exact same starting point but are not the same ray. These have the exact same starting point and they are the same ray. So what is needed for two rays with different names to be the same? Well, we know they have to have the same starting point, and then they have to extend in the same direction. So that is an important thing to write down, especially for some of the questions that will be asked. For example, are ray AB and ray AC the same ray if I do not provide a picture? There is no picture for AB. There is no picture for AC. Are they the same ray? Just based on reading those names. Are they always the same ray? Are they never the same ray? Are they sometimes the same ray? This is how we ask these questions. The answer is, well, sometimes. But if we're going to answer a question with sometimes, we need to provide a little bit of background. We have to explain to someone why sometimes. So I want to show a visual where sometimes they are the same and sometimes they're not the same. Here's point A, here's B, here's C. In this case, they are the same ray. So sometimes they are the same ray just because they have the same starting point. However, in this picture, they're not the same. In this case, ray AB is the set of points here, and ray AC is the set of points here. They are not the same set of points. So just because we have the same starting letter does not guarantee that they are the same ray. They could be, but it doesn't guarantee it. Next up, parallel lines. Parallel lines are coplanar lines that never intersect. These are two important things. A lot of people think that parallel lines are just lines that don't intersect. That's not enough. They have to be coplanar. Coplanar establishes then they have to go in the exact same direction. So we're going to experiment with other kinds of lines that don't intersect in just a bit. This little arrow right here is what you might see inside a textbook or on problems where that is intended to tell you these are parallel lines. Line M is parallel to line N. This is how you read the symbols. Line AB is parallel to line DC. AB, DC. Visually, they look like segments. We have to imagine that they go further forever and become parallel lines. All right, so here's a question. What line is parallel to line AH? So here's point A, here's point H. You have to visualize or draw in your own line there. And which of those choices is parallel to it? Is it BF, line BG, line CG, or none of those three? The correct answer is BG. Hopefully we can all see that, how those would be lines that go in the exact same direction and never intersect each other. Okay. We do have to be careful that AH goes down like this, BF here. If we actually visualize that, those two would never intersect. But they're not coplanar. A, H, B, and G are 4 coplanar points and can make parallel lines. A, H, B, and F would not be coplanar. That is why it's important to understand parallel lines must be coplanar and go in the same direction. Okay, skew lines is what we are headed toward, of those lines that they don't intersect, but they're also not on the same plane. So they do not lie on the same plane. They neither parallel nor intersecting. AB and CG, take a look. AB is the front up at top going side to side, and then CG is along the bottom going front to back. If we extended forever, they would never hit each other. Extend that blue line forever in your mind. Think of it as like the ceiling and the front wall. And then this is a side wall, and the side wall and the floor extending forward. AD going straight up and EF going left to right in the back. Those are skew lines. It's very important to understand that they are just not coplanar. Look at the 4 points. A, D, E, and F. A, D, and E make up the side wall. F, that's it. Those 4 points, not coplanar. The lines are skew lines. Now, we're going to get into the 3 types of lines here. And one of the things that we didn't talk about was intersecting lines. We know that skew lines are not coplanar. Parallel lines are coplanar. All 4 points have to be coplanar. And then intersecting lines. Why is it that intersecting lines always have to be coplanar? So let's draw this. Here's a pair of intersecting lines. I need 2 points. Remember yesterday, the other lesson, the first lesson, one basic postulate. Between any 2 points, there is one line. So, I need 2 points. Point A, point B. Now I have that one line, line AB. I also need another point in order to say line BC. So, line AB and line BC intersect. It takes a minimum of 3 points in order to create intersecting lines. And 3 points, according to the lesson from chapter 1, section 3, any 3 points are always coplanar. They either form a triangle, which makes a flat surface, or they were collinear. In this case, 3 points make a flat surface. Intersecting lines are always coplanar. Parallel lines like DC and AB, these A, B, C, and D, they are 4 points which don't have to be coplanar, but because they are, we're able to produce parallel lines. And then non-coplanar is skew lines. So we come to the final question of, can 2 lines be non-coplanar and intersect? And you have to think about, this could be a test question. How would you explain this answer? We might be able to look at this chart and easily say, well, no, that's impossible. But why? Here's one reason. If they did intersect, they have 3 points that are coplanar. So not coplanar and intersect cannot go together. Alright, now planes. As we move beyond to planes, there are only 2 types, parallel planes or intersecting. There's no such thing as skew planes. So, 2 parallel planes would be like the roof of the classroom and the floor, where if we extended it forever, they will never intersect with each other, and they are flat, 2-dimensional surfaces extending forever. However, the wall, the front wall, and the ceiling, those are examples of intersecting planes, and they form a line. This was one of our basic postulates from the first lesson, that if 2 planes intersect, they will always intersect to form a line. Now, there are not a lot of sample problems from this work that we can show here, but you have to use the information that was shown to explain your answers. And remember that postulates, between when 2 planes intersect, they form a line. That is a fact. You can use that fact to defend your answers. Here are a couple multiple choice questions that we will talk about when we come into class. And I want you to think about the idea of what would you say to explain them. If you're going to say always, tell me why. What fact makes it always? If you're going to say never, same thing. Tell me a fact that makes it a never. Sometimes, show me both. Sometimes it is, sometimes it isn't. Be prepared for both cases. You can pause the video here, make sure you have your answers, and we'll see you in class to see what you guys understood.